Phenomenology is a method of inquiry, and it was not devised by spiritualist people at all. This is science. To talk about how phenomenology is different as a science from objective science, which it is very different from objective science. Let me remind you of what objective science is like and what the scientific method is. And if you went to science, you learned all this, but in objective science, you construct experiments in a way that will isolate a single variable so that you can measure how one variable affects the outcome of the experiment. For example, the experiment of do heavy objects fall faster than lighter objects? You might think that, it kind of makes sense that heavier objects might fall faster than lighter objects. But if you have two objects that are of identical size, and one's heavier and one's lighter than the other, if you drop them, you'll find that they both hit the ground at the same time. And you can do that with any great variety of objects. Go from very light ones to very heavy ones. You can try it 100 times and they'll all work out the same way. People on the other side of the world could do the same experiment and they'll find that the answer is very regular. And in fact, you can generate a mathematical formula for figuring out how long it's going to take any object to get from point A, where you drop it from, to point B, to the ground, because we know how fast objects accelerate when they fall, because we've done this experiment. This is a very basic physics experiment. And they're looking for cause and effect relationships. And all of objective science is really about this kind of experiment. But all of physics is based on looking at the world as being systems of objects in space and time, and the cause and effect relationships between them. An object in motion will remain in motion until it comes in contact with something else, and any action will result in an equal and opposite reaction. These basic laws of motion, and scientists were very excited about this. To be able to quantify, to have equations that will allow you to figure out exactly what the impact will be when something hits if you throw it at this particular velocity. And so, having had such great results with physics and with chemistry, with objective science, they would like to believe that they can explain everything on Earth with objective science. And to the point that you can, that the universe is made of objects, and those objects can be broken down into smaller objects like molecules and atoms, and then can be explained by chemical reactions between atoms and molecules. In fact, many physicists believe, and many scientists believe, that consciousness is a byproduct of chemical reactions in the body. That the human body, according to the theories of objective science, especially according to objective scientists who believe, and many of them do, believe that objective science can explain everything in the universe, including consciousness. And that's their theory at this point, that the chemical reactions inside the brain produce something that we call consciousness. Now, this scientific method works very well when you're dealing with objects in space and time. It's been very effective, and that's why we have, that's why we can send rockets into space and all kinds of other things that we can do. It gives us a lot of power over, especially for making machines, because machines are all parts working together in cause and effect relationships. If you think about your car isn't alive or dead. Your car is a collection of objects that are all working together, and when they're all working together correctly, your car moves forward. If there's a piece missing, your car's not going to move. But you can replace that piece and your car is going to move. So machines are nothing more than the sum of their parts. And we've gotten a long way with that. Okay? But scientists, especially perceptive scientists and scientists studying perception and scientists studying biology, what's happened with objective science is that physics and chemistry are very advanced. They're almost complete and quite predictable. We can do a lot with physics and chemistry. And you didn't have to do a million experiments to come up with these equations that allow us to make predictions on how objects behave in space and time. You do a few experiments and you can make the equation and you can apply it to objects anywhere in the world. They're all going to behave that way. When you're dealing with organisms, it's a different story. And the phenomenon is that physics and chemistry are nearly complete, but biology and medicine are still very much in their infancy. You know, doctors would like you to believe that they know how the human body works, but they don't. And that's why there's so much debate on medical issues. Biology, like, we're just barely describing what's happening in biology. Scientists go out and they follow animals around, and they get a sense of what their behavior is, but organisms are a whole other story when it comes to science. And the more you get, the closer you get to consciousness, for instance, psychology. If you study psychology in college, you think that you're studying, you might want to go there thinking that you're studying the human mind. You're not. You're studying behavior, because behavior is what they can quantify about whatever goes on inside your mind. And psychology then increasingly becomes about manipulating behavior, what kind of things you can do to change people's behavior, or basically to change people's behavior. But it doesn't reveal much about how people think or why people think or what consciousness is at all. So a few scientists, starting with like Franz Brentano, who developed Gestalt psychology, the idea that an object is never a thing in itself. It's always against a background. What color something looks is determined as much by the color that it is as the color that's behind it. So this phenomenon of the object is affected, our perception of the object is affected by what kind of background is in it, is sort of made scientists curious about what it is about consciousness that causes us to have that experience. And they realized that that practically everything with regard to biology, and biology, sociology, psychology, they conduct a lot of experiments, and you've really got to study statistics if you're going to study biology in the through objective science. You can only isolate so many variables when it comes to organisms, because organisms are very complicated, and they all act a little differently. When you do objective science experiments on organisms, instead of having everything come out the same way, you usually have a bell curve. There are some people who respond more to whatever stimulus you're giving them, that you're looking for the reaction to, and then there's some people who won't. Even plants, the rate that plants take up water. There's a whole great variety of plants. Even if you use all the same kind of plants, there are variations among individuals that you can't eliminate that. You can't completely eliminate the variables, because the plants are a little different. Even if they're all clones from the same plant, they will have individual differences as they develop. So when you're testing like how much water they're taking in, you're going to find that the data is in a bell curve. Some of these plants don't take in so much water, some of the plants take in a lot more water, and you can take an average, but it's not nearly as cut and dry as it is with physics. Objects in space and time are very regular in their behavior, and organisms are just not. And that is a curious thing. And so, what are some of the things that make an organism different from a mechanism, from a machine? Like I said, everything that human beings build, we build with this cause and effect relationship. We build machines that we can build very complicated machines using these cause and effect relationships, and they're never alive and they're never dead. They're just a collection of parts that are all put in place so that one thing will cause an effect in the other. Okay? An organism is a little bit different, and we're moving from physics. Physics would tell you that this is a drop of water and air. And physics would also tell you that the things always move to a lower level of order. You know, your car is always breaking down. Your car never gets better. Your car never evolves, right? But a soap bubble is a very different, I wish these would float a little more. But, okay, a soap bubble, it's a drop of a solution in a perfect sphere around a quantity of air, such that the pressure outside the bubble is exactly the same as the pressure inside. And there's a 1 molecule thick membrane that covers the entire thing. Chemists can explain the solution of the liquid that we have here, the drop of water, and they could explain the solution that's in the air, and that they're both fairly chaotic. You know, solids like this rock, the atoms are much closer together and they don't move around so much. Things that are liquid, the atoms are more excited, and so it creates this fluidity. And when it comes to gases, they're even more active, so they float. You have a lot of chaos, but we're creating something that has a lot of order, right? These things are perfectly round, and they respond globally to localized stimuli. Okay, when I blow on the bubble,
that's nice.
Yeah. When you blow on the bubble, they change shape, they undulate in order to accommodate the air moving around them. And so why do all these molecules, there are, millions of molecules. There you go.
I think we should go through.
Okay, yeah, there you go. See if we can keep them in the air. We can get ones that float. That's really good. Okay, yeah, so this is a kind of suddenly we're looking at an organic system. And a soap bubble has all the characteristics, at least that we need to talk about for phenomenology, of an organism. It's a system, it's a complex system, such that that's greater than the sum of its parts. There's something more to a soap bubble than there is to just a drop of water and the air in the room.
Nice.
Yeah, there we go. You see, objective science doesn't really explain why that happens. I mean, it happens in science, and it's a phenomenon, it's an observed phenomenon. But to explain molecularly why this would happen, objective science can't do that. For a phenomenologist, the soap bubble is a very good example of the most basic characteristics of an organism. It's a complex system that evolved, it came out of chaos, right? It's turbulent air that we're blowing through this drop of soap. There's one that's floating. Okay. We're adding turbulence. We're not doing anything. There's no precision manufacturing in making a soap bubble. We're adding turbulence, and suddenly there's this higher order of organization that just spontaneously occurs. And that's a characteristic of our world that objective science does not recognize, or at least that there's not an explanation for it. That's a curious thing. My pleasure, thanks.
I'm not gonna take a look at that thing.
Yeah.
It's like a little deck.
No, this is a